Okay, so technically I'm ready to move on to relocatable object files, starting with ELF formatted relocatable object files. But before I move on to that, there is actually one bug that I want to fix in the encoder, along with a few just changes to fix some typos and sort of make the validation of matching forms a bit better. So the bug is actually one of the test cases. So if I go to the encoder assembly, we have this instruction vconvert ps to ph, and there's this SAE decorator here. But this instruction is actually invalid, and NASM has allowed it. It's invalid because SAE is only supposed to go from register to register, and this one has a memory destination. So this has happened because I've always assumed that SAE would be on the RM operand, which it basically always is. I think this is the only instruction that's the exception to that rule. And so my validation isn't catching this, and NASM's obviously isn't as well. So I need to remove this test case and make sure that it actually fails to match the instruction. So I'm going to keep this here to make sure that it fails to match, and then I'll remove it once that's happening. So if we do go test, this should be cached from the last time I ran it. So this is all passing at the moment. So if I go to operands match, so there are a couple of things to clean up in here, but one of them is basically to add a case to this reject logic to see if, if the destination, which would be op1, is memory, and then in this case it's op2. This is like an exception, so I'll just do it as op1 and op2 so if op1 is memory and op2 is SAE, then this should also be a case that we reject. So if we do a go test now. So this now fails on this instruction only, because this is the only one that actually has the problem. So that means I can now remove it from my tests, and we'll just regenerate the listing and do a go test again, and that passes now. So while I'm in here as well, though, just to sort of catch like decorators on incorrect operands a bit better, I just wanted to change these to be just sort of like bitwise comparisons to catch flags that shouldn't be going through. So if we start with, for example, getting all of the decorators that actually matter here, so if we just look for SAE, for example, so we'll go through opmask, zeroing, SAER, and broadcast. These are the ones that matter here, so I'll put these in a const called decorators. And just OR them together. So instead of checking which operand is this RM here, we'll just get rid of that. And we'll just say that a rejection is basically, so we'll do this for each operand. So we'll say, for example, op1 ANDed with decorators will just leave us with only the decorators that are on the operand that was passed in. And then if we clear all of the bits from the form operand, so f.op1, then if there are any left over, that means that I've got a decorator on an operand that shouldn't be there. So I can check to see if it's not 0. And basically I can just do this for each of the operands and just have this special check at the end for the memory and SAE thing. So we can change this one, for example, to op2. Then we'll have op3 and op4. So this covers all of the operands, and it will stop decorators getting through that shouldn't actually be there. There's also this vsib check. This is being done for both vex and evex. I could move this down to here and just see if vsib matches. Right now I'm just doing it on operand 1 and 2, which I think is fine, but it will be just as easy to just do this check for all of the operands and see if the vsib is a match between the operand that's passed in and the former operand. So basically, if the operand that's passed in has vsib, then the form should also have vsib. Or if the form has vsib, then the operand should also have vsib. So they just need to match in that way. So we could do something like saying if op1 is vsib, this will give back a true or false, and then we could say like if it's not equal to f.op1 is vsib, then that will also give back a true or false, and if they don't match each other, then it means that something's wrong here, because in the case where we're using vsib, it must be on both the form and the operand in these cases. So we want to check that all of these actually match, so we could say that instead of not equals, because that would be a mismatch, we'll do equals, and we'll check that all of the operands match for vsib. So this one will become 2, 3, and 4. And then we can just return vsib matches. So that means I can get rid of this vsib check here. I can get rid of it here as well. Then there's a case where in legacy, I should really be checking to see if anything requires evex in this case. So we'll just take this and get rid of reg high, because reg high is okay in legacy. We can move this info thing out here, which means we can get rid of it from here. And I think that should be everything. So hopefully these all pass still. Okay, yeah, so those all still pass there. I did see a couple of typos throughout the code base. So let's see, we've got, I think it's up here, I got the comments mixed up. So these ones actually do not have a mod RM. So we'll just go and switch these comments around. Then there are a couple of typos in like tests, I think. So I think I did label name. Was it label name or... Oh, this is encoder. We go to encoder test. I think it was label name. I missed a couple of renames here to offset, so that was just a copy-paste problem. I'm pretty sure there was a typo down here somewhere. I think a bit further down maybe. There's somewhere. Oh, here's one. This should say VVVV. Let's see. This one is legacy. This one's vex. So this one should say vex cannot encode evex attributes. Then I think that covers typos that I had seen. I did want to change the new instruction to return an error as well, because this will be something that I can use in the assembler layer, so that when I'm building an instruction, I can just see if it matched or not without having a panic the whole time. And then that can be used to obviously give some better error messages to the user. So here we'll just have like a 0 instruction and an empty error. So instead of a panic down here, we'll just return 0, and we'll say error no matching form. So let's just put this up here. So this will be var error no matching form equals errors.new no matching instruction form. And then here we'll just put this into a variable and return like that. But now I'll need a helper here. So we'll say errors x as a new package. And I'll just do a generic must in here. So this will be must. We'll take t any, and we'll accept a value of t and an error of error. And we'll just return t. So if error does not equal nil, then we'll just panic on it. Otherwise, we'll just return the value that we got back. So that means now that in the benchmark for matched, where I use this new instruction, I can just wrap it in errors x.must. Let's just do a test. Okay, that's all okay. So we'll do go test bench. Let's just say count equals 1. Is that right? Oh, I need to do equals dot. Okay, well, we'll just do 5 then. So this is about what I'd expect with OBS running. I think without OBS running, it should still reach up to about 100 million and 180 million, but that's just with, you know, it's pretty small changes in the nanoseconds can cause this now. So that is one of the other changes I wanted to make. I'm pretty sure there was something else that I saw in here. Oh, I have this clear function. I forgot to add clearing the code to this. And now that I'm looking at that, there's actually a recover in the tests. Let's see. I think it's in just the normal tests here. So this recover is actually going to stop any other instruction tests as well. So I just want to wrap this in a function so that the defer happens at the right time. And since it's looping through now, I'll do the clearing the code at the beginning of the defer. Okay, so that's all okay. Let's just see if the benchmarks are still okay. I assume they are. Yep, okay, that's all fine. And I think that's about it as far as I can see. Yeah, so that was just a little bit of a cleanup and a genuine bug in the vconvert ps to ph instruction, which now shouldn't cause any problems.